Hello everyone and welcome to class of Kubernetes Engine. In our last class we have discussed about the compute engine. Now let's start with Kubernetes Engine. It is a Google Cloud Platform managed Kubernetes service. With this service, Google Cloud Platform customers can create and manage or maintain their Kubernetes clusters without having to manage the Kubernetes platform. Kubernetes run containers on a cluster of virtual machines. So here we require to create a cluster. So in this cluster, it runs various virtual machines. It determines where to run containers, monitor the health of the containers, and manage the full life cycle of a virtual instances. This collection of tasks is known as container orchestration. Like we have instances groups. Instances groups are quite similar to Kubernetes clusters, but both are the sets of the virtual machine that can be managed as a group. Instances groups are much more restricted. All virtual machines generally run the same image in an instance group. This is not the case in Kubernetes cluster. This is the basic difference between Kubernetes cluster and the instances group. Also, instance groups have no mechanism to support the deployment of cluster. Deployment of clusters are there in Kubernetes. Containers offer a highly portable, lightweight means of distributing and scaling your applications or workload like virtual machine without replicating the guest operating system. So a Kubernetes cluster consists of a cluster master. Here we have cluster master and one or more nodes which are workers of the cluster, master and workers of the cluster. The master controls the cluster and can be replicated and distributed for high availability and fault tolerance. The master manages services which are provided by the Kubernetes such as APIs, controllers, schedulers. All interactions with the cluster are done through the master using the API. The master issues the command that performs an action on a node. User can also interact with the cluster with the command kubect1 command. Nodes execute the workloads. We have the workloads and nodes execute these workloads which run on a clusters. Nodes are basically virtual machine that runs containers which are configured to run an application. Nodes are controlled by the master, but some commands can be run manually. The nodes run an agent which is known as kubelet, which is a service which communicates with the master. When we create a cluster, we specify a machine type like N1 standard one with 1 vCPU and 3.75 GB of memory. These virtual machines run specialized operating system optimized to run the containers. Some of the memory and CPU is reserved for the Kubernetes, so is not available to applications which are running on a node. Kubernetes organizes processing into workloads. There are several objects that make up the core functionalities to process these workloads. Now in Kubernetes we have some Kubernetes objects. These workloads are distributed across nodes in a Kubernetes cluster. We have pods, services, volumes and namespaces. Pods. Pods are the single instances of a running process in a cluster. Pods contain at least one container. They usually run a single container but can run multiple containers. Multiple containers are used when two or more containers must share the resources. So pods are used for shared networking and storage across the containers. Each pod gets a unique IP address and a set of ports. Containers can connect to the port. Multiple containers in a pod connect to different ports and can talk to each other on localhost. A pod allows its containers to behave as if they are running on an isolated virtual machine, sharing a common storage, one IP address and one set of ports. We can also deploy multiple instances on the same applications or different instances on different applications. Pods treat the multiple containers as the single entity for all the management purposes. Next is services. Since pods are ephemeral and it can be terminated by the controller, other services which depends upon pods should not be tightly coupled to a particular pod. For example, even though pods have a unique IP address, applications should not depend upon that IP address to reach a particular application. If a pod with that address is terminated and another is created, it may have another IP address. The IP address may be reassigned to another pod running on a different container. Kubernetes provide a level of indirection between applications which are running in pods. And other applications, we call them services. So a service in Kubernetes is an object that can provide API endpoints with a stable IP address. It allows application to discover pods running on a particular application. Services update when changes are made to the pod. So we require to maintain an up-to-date list of pods running on an application. We have replica set. A replica set is a controller which is used by a deployment that ensures the correct number of identical pods are running. For example, if a pod is determined to be unhealthy, a controller will terminate that pod. So the replica set will detect that not enough pods for that application or workloads are running. It will create another. Deployment. This is an important concept in Kubernetes, which is deployment. Deployments are sets of identical pods. The members of the set may change as some pods are terminated and others are started, but they are running on the same application. The pods all run the same application because they are created using the same pod template. So a pod template is a definition of to run a pod. So we require to describe a pod. For that we have stateful set. Deployments are well suited for stateless applications. Those are applications that need not to keep the track of their state. For example, an application that calls an API to perform a calculation does not need to keep track of the previous calls or calculations. So an application that calls that API may reach a different pod each time it makes a call. Now, stateful sets are like deployments, but they can assign different unique identifiers to pods. It enables Kubernetes to track which pod is used by which client and keep them together. So stateful sets are used when an application needs a unique network identifier or a stable persistent storage. Now we have a job. A job is an abstraction about a workload. Jobs create pods and run them until the application completes that particular workload. Thank you so much.